I wanted to make a short video, if I could, explaining limiting reagent. It's a concept that's throughout chemistry, whether it be organic chemistry, general chemistry, that is difficult for students. So I thought I'd try to use an analogy from a breakfast plate or platter. You might consider not a drawing of a man here, but 2 eggs, sunny side up here, and 3 pancakes as what we'll call a full house breakfast. So here's our, again, breakfast plate, and the plate, to make a breakfast plate, we need 2 eggs and 3 pancakes. I'll just put pans. I guess I got enough room. Pancakes. So if 2 eggs plus 3 pancakes makes a breakfast plate. So that's a picture of combinations that result in a full new unit called a full house breakfast plate. So that's kind of the idea we can use when we come to reactions. We can say, well, I have 3 of, I'm just going to say X and plus 2 of Y element, and we can combine those to make X3, Y2, some compound. That's really all we're doing in organic chemistry, organic, or I guess inorganic. As far as reactions, we have some combination of reagents going to products. We're not making full house pancake or breakfast plates, but we're making products from reagents. We're changing the reagents to make, in some combination, addition, whatever, some product. We're combining these two to make a breakfast plate, 2 eggs and 3 pancakes. So kind of in that same idea, then, if a person found out they have, let's say, two cartons or 24 eggs. They had 24 eggs. And as far as pancakes, the fella or lady in the back, whoever's working for you, takes all the batter and makes 24 pancakes. So what you could do with that batter that you've completely consumed, and you've made a number of pancakes, 24, and you've taken 2 cartons, and there are 12 for each carton, so you have 24 eggs, you can try to figure out how many breakfast plates can I make. You can try to figure out how many breakfast plates you can make. Well, what you need to know then, if you want to do that, is you want to know which of these is sort of limiting. Which of these is going to be consumed, and thus limit what number of breakfast plates I can make, if I can spell pancakes here. So 24 pancakes and 24 eggs. Now, just qualitatively looking at this, we can say, oh, I think I'm going to have my limiting reagent be the pancakes, because I have to consume more of these for 2 eggs. I have to consume 3 pancakes to make a full house breakfast plate. So I would need a 2 to 3 ratio of eggs to pancakes if I was going to make if I was going to completely consume both of these. I would need to have more pancakes than eggs, because it's a 2 to 3 relationship, and this is certainly not a 2 to 3 relationship. To be 2 to 3, it'd have to be 24 to 36. So qualitatively, just looking at it, it can sometimes be easy to see what your limiting reagent is. Sometimes it's not. So what you'll need to do to sometimes figure out your limiting reagent is to take these 2 separately, or just one of them, and from it determine how many of the other, I guess, dish we need to make a complete full house breakfast. Well, we can take the 24 and say, what I want to do is consider if all of this was consumed, all consumed, how many pancakes would I need? To do that, you use a molar conversion. Well, I guess the equivalency of molar conversion. You can see what I'll do is I'll divide it by its own unit in front of the balanced reaction that makes the full house breakfast plate, 2 eggs, 3 pancakes, its own coefficient divided by 2, and multiplying it by the coefficient in front of the pancakes. And you say, well, why do you do that? Because what you're doing basically is you're setting up a ratio that you're going to use to, you're going to say 2 eggs cancels out with 3. Just going to put pan. So you could cancel these, 24 times 3 divided by 2. That would give me the number of pancakes if this is completely consumed. So 24 divided by 2 is 12, and 12 times 3 is 36. We would have to have 36 pancakes if all of this was consumed, because we used the conversion to 2, dividing it by its own coefficient, and timesing it by whichever one we're going to. This, we want to know the number of pancakes. We would have to have 36 pancakes. Do we have 36 pancakes? No, the lady or guy yells from the back, I only have 24. So you would say this is the limiting reagent. You have less of it than what you need. So you can stop there and say this is the limiting, our limiting side, or limiting, I'm just going to put reagent. We're going to use that term. So you can say this number sets how many breakfast plates I can make. So you can just divide this 24, because you know you have to take 3 pancakes each. You can divide that by 3 and you get 1 breakfast plate. So the same thing we did from looking at finding limiting reagent, we can do to find the number of breakfast plates we can make from this limiting reagent. This is our limiting reagent. We can take it and divide it by its own coefficient, 24 divided by 3, and multiply it by the coefficient in front of the full house breakfast plate. 24 divided by 3 and times 1 would be 8 plates. Took me a little while. Alright, so 24 divided by 3, we can make 8 full house breakfast plates. Now we can do the same thing over here. If we found we had 10 moles and 10 moles, and we needed to know which of these is the limiting reagent. So by molar mass, if they gave you weights of these and you divided by the molar mass, and let's say you found the mole amounts of these two to be exactly 10 for this and 10 for this, how would you find limiting reagent? Limiting reagent. You would take any one of these two. I'm going to just work from the left side and say, well, if I have 10 moles of X, and I want to know if completely consumed how much of this I would need, I can times it by the molar conversion. I can say 10 moles of X, I can say that I have 3 moles of X for every 2 moles of Y. So again, taking that, just the left one, doesn't matter, and it's saying if completely consumed, how much would I actually need in moles of Y? 10 divided by 3 and times 2. So looking at 20 divided by 3, I don't have my calculator in front of me. Okay, 6 times 3 is 18, so we'll just say approximately 6 to 7 moles of Y is needed to completely consume this. So we certainly have, if we look at this, we certainly have more than that. So this is not our limiting reagent. We have 10 moles of Y. We only need 6 to 7, and that kind of, again, qualitatively makes sense. We have to consume 3 of these for every 2 of these. In other words, we need to have 30 to 20, not an equal 10 to 10, or 15 to 10. We would need to have 15 moles to 10 moles if both of them were consumed. So this is our limiting reagent. Hey, I like that. This one we saw is kind of different. We calculated that we have more than what we need. Over here, with our little analogy of eggs and pancakes, we found that we don't have enough pancakes by taking that left given value and seeing what the mole amounts or numbers of pancakes would need to be to completely consume this. So that's how you can calculate limiting reagent. It's just to think about the full house breakfast plate. Make sure if you take those 2 numbers given of actual items, moles and moles, like eggs and pancakes, just take the one number, left one doesn't, or right, doesn't matter, and go through the conversion. Divide it by its own coefficient and multiply it by the coefficient for the other reagent that you're wanting to look at as a possible limiting reagent. So divided by 3, multiplied by 2, we saw that we get a smaller number than what we actually have. So we have more than enough. This became the limiting reagent. Hope that helps getting you from the just moles of reagents to the determination of limiting reagent.